Shubhashi Shiksha, Shubhashish, my dear children of 10th standard. Don't worry, 9th standard students, I'm coming up with my first lesson for you, Maths Without Fear. That will be started. I was going to the notes of NCRT and I heard the name of Carl Friedrich Gauss, a famous mathematician who did wonderful work in electricity and magnetism and gave us Gauss theorem. He wrote beautiful books in 1770. He belonged to a very poor family. Okay. Then it was Wilhelm Weber, who continued with the great work. This Gauss was responsible for giving us the fundamental theorem of mathematics. Carl Wilhelm Weber, he gave us the first electromagnetic telegraph. He gave us the electromagnetic telegraph. After that, there was Graham Bell and other people who invented the other inventions in the same field. Yesterday I showed you a diagram. We call it Eureka can. I have found the Eureka का मतलब I have found the answer. मुझे मिल गया है जवाब. तो जल्दी से कहानी बताता हूँ कि आर्किमिडीज जिन राजा के पास रहते थे उनकी कोर्ट में बहुत बाकी सभी जो कोर्टियर थे या दरबारी थे वो चिढ़ते थे उनसे. एक बार एक आदमी आया और उसने कहा कि मेरे पास ये क्राउन है, प्योर गोल्ड का है और प्योर गोल्ड के इस क्राउन की कीमत जो है वो इतनी है. जितने भी दरबारी थे उनको लगा कि ये मैथमेटिशियन है, बहुत ज़्यादा हर वक्त राजा इसकी प्रेस करते हैं, तो क्यों ना आज इसको फांस दिया जाए. तो उसने कहा कि महाराज ये बहुत अच्छा मैथमेटिशियन है, तो इससे कहो कि बिना इस राजमुकुट को तोड़े ये इसकी प्योरिटी बताए कि ये प्योर है या नहीं है. राजा को भी लगा कि क्यों ना इसकी खिंचाई की जाए, है ना, राइट, ताकि दरबार में कॉन्फिडेंस डेवलप हो. उन्होंने कहा कि कल सुबह से पहले यदि आपने ये मेथड नहीं बताया कि ये प्योर गोल्ड का बना हुआ है या नहीं बना हुआ तो आपकी गर्दन काट दी जाएगी. आर्किमिडीज को नींद नहीं आई कि ये कैसे होगा, है ना, ये कैसे होगा. तो जैसे ही उन्होंने सोचा कि अब कल तो मरना ही है, तो उन्होंने क्या किया, उन्होंने कहा कि अपनी वाइफ को बोला कि मेरे लिए नहाने का टब तैयार करो, मैं नहा धो के ही सोऊंगा, ताकि क्योंकि सुबह मुझे जाना है और पता नहीं क्या होगा सुबह. जैसे ही आर्किमिडीज पानी में बैठे, पानी का लेवल राइज हुआ. वो फिर बैठे, फिर लेवल राइज हुआ, एंड इमीडिएटली ही गॉट द आंसर ऑफ द प्रॉब्लम. And he ran out naked, shouting on the streets, Eureka, 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 I have found the answer. The principle was very simple. उसने राजा को बोला कि जितने वेट का ये गोल्ड का क्राउन है, इतना ही वेट का प्योर गोल्ड मुझे दे दो. और यूरेका कैन उसने बनाई. यदि दोनों की डेंसिटी क्या होता है, मास पर यूनिट वॉल्यूम सेम होगा, डेंसिटी सेम होगी, तो ऑटोमेटिकली दे विल डिस्प्लेस इक्वल वॉल्यूम ऑफ वाटर. और जो डिफरेंट होगी, उनकी डेंसिटी अलग होगी, तो दे विल डिस्प्लेस डिफरेंट अमाउंट ऑफ वाटर. Archimedes, the law of flotation. Let us continue with the second part, rationalization, irrational number and rationalization, the process of rationalization, that is rationalizing the denominator, not rationalizing an irrational number. We are continuing from where we left. This is being recorded again. The voiceover is being done. There may be slight shifting here and there. What has happened is we were discussing fundamental theorem of mathematics and the concept of uniqueness, which states that whenever 72 is written here with 2 into 2 into 2 into 3 into 3, 2 raised to power 3 into 3 raised to power 2. Okay, when this is written, it means here 2 and 3 are its prime factors. Okay, 2 raised to power 3 into 3 raised to power 2. Here 2 and 3 are its prime factors. That means any number can be written as a product of this prime factor raised to a certain power. Okay, so it is written this number is equal to p into p1 into p2 into p3 p into p4 up to pn, whatever is the number of prime factors possible, and these are unique. These are unique. Okay, this was given by Frederick Gauss in the form of Gauss theorem. He gave Gauss theorem for magnetic and electrical field. Nowadays we are reaping the harvest of his theorem. And then Wilhelm Weber, who invented and made the first electromagnetic telegram from the same. Everything is being done accordingly. Okay. Rational numbers and irrational numbers we have to visit again, and we are visiting again. Rational number is written as a Q. Rational and irrational numbers we are revisiting. Q is equal to a rational number. We are writing the set builder x such that x is equal to p by q, where p and q belong to z. P and q are co-prime and q is not equal to 0. The denominator, as it is p by q, the denominator should not be equal to 0, otherwise it will become infinity. This property that p and q are co-prime is very important. It should be noted. That means they are not they cannot have a common factor. If they have a common factor, that's not a perfect fraction or a rational number. Q dash is as the set of irrational numbers which states that, like square root 2, I have written square root 4 also. Okay, square root 2, and square root 2 is neither terminating, that is non-terminating and non-recurring. Under root 4, it has got two values, plus minus 2, right? Basically it is modulus 2, so it can have two values, plus minus 2. Whenever we are dealing with the operations in between irrational numbers, then there is a concept called rationalization of the denominator. For example, 1 upon under root 3. So we multiply by a suitable real number and we divide by a suitable number, so that it turns into square, and square root gets cancelled. It becomes under root 3 by 3. We can take one more expression, 1 upon under root 3 plus 2, using the formula a square minus b square, which is equal to a plus b into a minus b. So if a plus b is given, we have to take up a minus b, and if a minus b is given, we have to multiply and divide by a plus b. In this case it is under root 3 plus 2, so multiply by under root 3 plus minus 2 and divide by under root 3 minus 2. Below in the denominator we apply the algebraic identity a square minus b square, and the value becomes under root 3 minus 2 divided by 1 as solved. The next type of questions, as it is written, so 3 minus 2, which is equal to 1. Under root 3 the square minus under root 2 the square, it is equal to 1. So here the denominator is rationalized. Then there is one more theorem proving that the given irrational number is a rational number. Okay, right? So what do we do whenever, and suppose under root 3, so basic principle followed is the same which we have discussed earlier. We know that p and q, any rational number, can be written in the form p by q. Irrational number, let's say under root 2, under root 3, under root 5, under root 7, they cannot be written in the form p by q. So what do? We prove that this is an irrational number. We prove that by contradiction. We suppose the contrary. So what do? We say suppose under root 3 is rational. Let us suppose that under root 3 is a rational number. So if it is irrational, then that means this number can be written in the form of p by q, where p and q are co-prime. Keep in mind, this property p and q are co-prime is very important. This has to be taken into consideration. So p by q is equal to under root 3. P by q is equal to under root 3. P square is equal to 2q. Squaring both sides. Now, what we p square is equal to under root 3 the whole square, cross multiplying p square is equal to 3q. It means p square is a multiple of 3. Now already we have done in the basic fundamental theorem of mathematics, if square of a number is divisible by a certain number, then the number also is divisible by the same number. So if p square is a multiple of 3, then p is also divisible by 3. Okay, p square is a multiple of 3, that means p square is divisible by 3, so p is also divisible by 3. So p can be written equal to 3r. Let us take p is equal to 3r. You can suppose anything, you can take anything, but generally we do not use x and y, x, y and z, which are the main Cartesian coordinates. We take a, b, c, we take p, q, r. You will understand slowly and gradually all these things, where and when we use different types of constants. So now we put the value of p square in the above equation. P square is equal to 3q. When you put the value of pq here, it becomes 3q is equal to 9r square. I have interchanged, though it is not allowed algebraically, but I am still doing it. So q is equal to 3r square now. So if q is 3r square, it means q is a multiple of 3. Now what have we proved earlier? That p is a multiple of 3. What I have proved here? Q is also a multiple of 3. That means p and q are not co-prime. It is contrary to what we have supposed in the beginning, that p upon q is a rational number. So if p upon q, p and q must be co-prime. P and q must be co-prime. They should not have a common factor. So if they are having a common factor, that means our supposition is wrong. Under root 3 cannot be equal to p by q. Therefore, under root 3 is an irrational number. So the contradiction arose, and when the contradiction arose, automatically p by q is not equal to under root 3. Therefore, under root 3 is an irrational number. That's called proving by contradiction. We suppose the opposite and then we prove that it is wrong. In the next diagram, it is given page 1 that HCF and LCM, their product is also equal to the product of first number and the product of second number. Richard Dedekind is called the father of modern science, modern mathematics. He was founder of real numbers, continuity and irrational numbers. Okay, the concept of complex numbers was introduced. What is a complex number? There is no square root of -1. It is called iota, small I, and it's called an imaginary number. Any square root or cube root, square root in this case, we are not going beyond that. Suppose minus under root 3. So minus under root 3 is written as under root 3 iota, taking -1 as iota. This is imaginary number. This we will be studying in 11th standard. Okay. It's good to continue maths up to graduation. Maths is the most important subject, I tell you very clearly. Okay, it's just like the other making programming algorithms helps you, this also help you. There's one more very important question, that suppose there's a number prove, I'm taking it from NCRT, prove 4 upon n cannot be cannot have a digit ending with 0, cannot have the unit digit ending with 0. Now all of you know that whenever we divide a number by 5, so divisibility arises only when the last digit is 0 or 5. Okay, if you express this number 4 raised to power n in two forms, 2 raised to power 2 into n, what do you find out? That this number cannot have 5 as a factor. Okay, 5 cannot be a factor of this number. If 5 is not a factor of this number, 2 and only 2 is the unique factor of 4 raised to power n, whereas 5 raised to power n is not a factor, because 5 raised to power n means 5 into 5 into 5. Even in case of 5 raised to power n, you cannot have units digit as 0. Okay, ones digit or units digit cannot be 0, because whenever you multiply any number by 5, 5 raised to power n becomes equal to multiple of 5. The last digit has to be 5. So exercise 1.1 and exercise 1.2 will be discussed, NCRT, with multiple questions. Okay, I'm just touching the HCF and LCM part in slightly here, that HCF, how to find out HCF. So suppose we are finding out 72 and 74. 72 can be written as 2 raised to power 3 into 3 raised to power 2 by short division method. 144 can be written as 2 raised to power 4 into 3 raised to power 2 by short division method. Okay, so HCF is the minimum common. In 2 upon 3 and 2 upon 4, the minimum common is so once again, suppose we have 10 raised to power n. So 10 raised to power n is equal to 2 raised to power n into 5 raised to power n. This can have 0 as the last digit, otherwise no. Because there must be an even number, and that only even prime number is 2. Then there is one more addition, that is 3 plus 2 under root 2. It's called rational number plus irrational number. How to prove that this is an irrational number? How to prove that sum of a rational and an irrational number is a irrational number? So HCF and LCM example is given once again. I am noting it down for you. Though I have already recorded, I have already requested that there must be some timing issue when we re-record audio. But don't worry, I hope you don't mind it. So this factors issue, because Euclid's division algorithm, that dividend is equal to quotient into divisor plus remainder, that we have already discussed, right? Okay, the short division method also we have discussed. When we are using a decimal system actually. Okay, how to find out 72 and 73? Factorization. Quadratic equations, you will be doing it again, will be revising it, x square minus 2x, factors rather, I am not taking quadratic equation. How to factorize a polynomial, a quadratic polynomial with order 2 by dividing the middle term method. Okay, so the coefficient of x is sum of the multipliers which we are choosing, and the last term constant is the product of these two multiples. So we have taken x square minus 7x plus 10, 5x cannot be taken. 7 is the sum and 10 is the product. So we choose the suitable number. The factors of 10 are 2 and 5. So 5 plus 2 is 7 and 5 into 2 is 10. Now because the sum is negative, so both have to be taken as negative. When we take common, it becomes x into x common, x minus 5 minus 2 common, x minus 5. X minus 5 is again common, is taken x minus 2. Okay, so x minus 5 and x minus 2 are the factors of this polynomial. If we put it equal to 0, we can calculate zeros of the polynomial from here, or you can call it the roots of the quadratic equation. So any equation becomes equal to quadratic equation once it is added. Thank you very much. May God bless you. See you again in the next part, solving the exercises.